Welcome to Weathered Questions, where we answer the questions on your radar.
Welcome in, everyone. This is episode 2, year 2 of Weathered Questions. Myself, meteorologist Kaj O'Mara, along with meteorologist Jan Kaj. This all started from a text message idea about a year and 3 months ago, and here we are, still cooking right along. And today's episode is going to be all about radar and all about the different colors that you see on those different apps and what you see on television and how meteorologists might actually use this. But first, we're going to change the order of things a little bit today, Jan. Normally we wait till 15, 16, 17 minutes in before the trivia question comes in, but we're going to start with a trivia question right now. So, hey, Jeff, I'm going to need your help, bud. You got it?
Today's trivia question.
All right, here it comes, Jan. Weather radar sends out pulses of what? Is it A, radio waves, B, sound waves, C, light waves, or D, laser beams? Think about those 4 possible options. We will have the answer for you here momentarily. All right, your 4 possible options again as you continue to debate. Radio waves, sound waves, light waves, or laser beams. Jen, what do you think?
I mean, based on how you said it, it's gotta be laser beams, right?
Arm the laser. Gotta be.
So this one's radio waves.
Yes, it is.
Yeah.
Oh, yes, it is. So
some people are probably a little surprised by.
Yeah. That's actually what radar is. Radio detection and ranging is what radar stands for. And it is radio waves that are all sent out there. And we think about the different types of radar. There's NEXRAD radar, which is an acronym for Next Generation Radar. There's also what we hear WSR 88D, the Weather Surveillance Radar 88 Doppler. You just think of it as radar as you're looking at apps and looking at your TV screens. But I'm a little bit older here with the radar that I've seen. Jan, would you care to tell everyone about some of the things that you've noticed in radar, some of the color displays you've noticed, and maybe what radar is capable of today versus when I was growing up?
Well, I mean, I'm not going to do any comparisons. We'll just say this is where we're at, right? We won't make anyone feel bad. So radar, like you said, right now, our network across the country is those WSR 88Ds. The fun way to say that, something that literally, nobody who's not a meteorologist probably cares about. But basically to say that all the radars across the country that the National Weather Service use and that your favorite weather app uses, I can almost guarantee, are all those same radars. Even if the color display on your app looks different from your friends, looks different from their aunt's app, looks different from their dad's app, they're all using the same radar. That's the beauty of having that public data. But there are different color tables and different things that may be being applied in order to show different things. And we'll get into a little bit of that here. But one of the things that we have come to be very familiar with here recently is dual pole radar. So dual pole basically means dual, two, and pole is that shortened polarization. So basically those waves that we just spoke of with our trivia questions, why we kicked off with the trivia question, because we're going to dive into all this radar stuff here today. It's sending out a horizontal and a vertical pulse, dual, okay? And it's reading whatever it hits, and it's sending back that data. So it might be sending back that maybe this thing that it hit is longer or taller than it is wide, or something like that. And what that does is it helps us understand the type of precipitation that it's hitting. Usually precipitation, sometimes it's other things. Sometimes it's a airplane or the top of a building, depending on where you're at. But we like to use it for precipitation. So that's what your dual pole is going to be. Now with that, way back when, we had one pulse sent out, came back, it said there's something there. Now, because we have those multiple, that horizontal and that vertical, and we can go at different tilts in the atmosphere, we can see a lot of different things about it. So we can see the most common thing, reflectivity, which is going to be what you would see generally on any of your radar apps. It's going to show you there's precipitation here or there isn't, or there's heavy precipitation here or there isn't. Now we can use all those things to help us understand the velocity, the wind that is happening within a storm. Is it going away from the radar? Is it going toward the radar? We can use it to understand something that we call correlation coefficient, which is going to help us understand tornado debris. And we can get into that in a little bit. There's all kinds of things. There's spectrum width. There's differential reflectivity, storm relative velocity, storm relative, differential. All those things can kind of compare things. There's also derived things. So those first ones that we mentioned, basically just straight up data. Derived, there's a lot of calculus in meteorology. And so we can manipulate those numbers to understand different things as well. Maybe it's the amount of precipitation that's fallen. Maybe it is the exact type of precipitation, the hydrometeor classification. We can look at something called echo tops, which basically tells us about how tall those clouds are. Vertically integrated liquid. Again, lots of big fancy words coming out of my mouth right now, but all of these things we can look at and tell us about the hail, the wind, the different things happening within a storm, all because we have a horizontal and a vertical pulse of radar that is being sent out and coming back to that same central point, which is that radar.
Yep.
The
most common product by far is going to be the general reflectivity.
Yes.
That a lot of folks are going to use. And reflectivity has been around for decades. In its most simple sense, now, if you want to torture yourself, you could look at something called the radar equation. If you just Google it, you can keep on going. And that's why we need to take up through Calc 3 in meteorology before we can really even touch our core courses.
And DiffEQ.
And differential equations, which was unfortunately a summer course for me. It was awful.
Ooh.
But it worked. It was okay. It worked. It was all right. But the thing was, that is the most common because that's what most everyday folks are going to look at. And you're going to see that display. And a lot of times you're going to see a yellow and a red, maybe a pink, and you'll say, okay, that's bad. Green, not as bad. And then if there's nothing there, okay, we're probably dry. Good chance we're dry, but as you'll hear later in the podcast, maybe not. So what does it even measure? If we have radio waves coming out and the radome is a big circle and the actual dish is shaped in such a way that it wants to get power back to it, reflectivity is exactly what it sounds. How reflective is the object? How reflective are the objects? And how much time does it take, number one, for my pulse to come back? That's how we know how far it is from the radar site. Number two, how much power comes back? Because that's what reflectivity is really measuring, the power return of that pulse. If a lot of power is coming back, you have a very reflective target out there. And that could be a number of things. That could be a hillside. That could be a building. Could be a hailstorm. And maybe it's a hailstorm that has a few golf ball sized hailstones in it. Or maybe it's a hailstorm that has a truckload of pea-sized hailstones in it. Regardless, it's extremely reflective. Dry hail won't be as reflective as wet hail. And so when you look at just straight reflectivity, yes, it can show you likely trouble spots, but it might not be able to do the greatest job as you think to depict what type of precip you're looking at. And that's where you need the other ones.
Yeah, that I think gets into kind of the core of why this episode came about is so many people will look maybe at a radar display and say, oh, it's going to rain. Oh, there's heavy rain coming.
Yeah.
And that's not always the case. And we wanted to kind of get into a little bit more of why you might see something on radar that isn't maybe exactly what's actually happening, either the ground truth or just those nuances in radar meteorology that the general public maybe isn't normally always aware of, but that we can use our platform here to help you be a little more knowledgeable on.
Right. Your most common products that you're ever going to see in television are going to be your reflectivity ones, and then also what they call velocity ones. And what's happening is the radar is measuring how much something is moving along that radar radial. It's not a perfect depiction of wind direction, because velocity and wind direction are a little bit different. But it at least gives you an idea of where things are flowing away from the radar site and where things are flowing towards the radar site. That's why whenever you see severe weather coverage, proper severe weather coverage should be toward the radar and away from the radar, not here's where the winds are north and here's where they're south. Because at the surface level, it might be a bit different. But from the radar's perspective, if you see something like that that's kind of trying to circulate, that's kind of a precursor of a potential tornado situation you might look for. Likewise, if you're looking at a hail event, the higher up the reflectivity gets, especially if it's like 40,000 feet or higher, you got yourself a pretty large storm. It's cold up there, like 30 degrees below zero cold, maybe even colder than that. And hail is going to be growing like crazy in that layer. And so if you have that much reflectivity up there, you know it's not rain at that point. You know you're dealing with a lot of ice. And so typically high reflectivity at the cold altitudes gives you a really good idea of you've probably got some hail in that storm. And then that can get us, Jan, into something that is a little bit outside of direct measurements. It's radar estimations of things. Mm-hmm. Because, we joked a lot. We could build probably a whole weathercast off of radar and its products. If it's a rainy day, you can see your current rain. You can see an estimation of how much rain actually fell. It basically takes radar reflectivity and does some wizardry to it. You can see the maximum estimated hail size that may have fallen. It's not ground truth, but it's an idea based on what was measured aloft of what kind of hail you might have. Mm-hmm. And in some storms, it actually does a pretty good job. But in other storms, maybe they're too tilted, maybe they're moving too fast. It may not do as great of a job. But all that data is there. And that I'd say that's the two biggest things I would always look for is where do we see any rotation at? Where are we seeing super high reflectivity aloft? Because that kind of covers a lot of the hazards of the general public, I think.
Yep. I think, yeah. I'm just trying to think if there's anything else we need to cover on that, or if I think we hit that one pretty well. I think so. If you still have some other questions though on maybe what we're looking for severe weather and stuff, please, by all means, send in those questions. We would love to talk through them. I am going to flip this though a little bit, and I think radar comes in a lot in the summertime. Because people are so interested in severe weather and tornadoes, and rightfully so. But there's a couple other things, some nuances in the wintertime that we can see. To your point, Kai, you talked about hail and bright reflective things. Somewhere that comes in is winter and snow, and especially when you have a melting layer of snow. We can get something on the radar that we refer to as bright banding. And essentially it gives us kind of false data that suggests maybe that there is especially heavy precipitation somewhere when that's not maybe actually what's happening. It's really just water-coated precipitation, water-coated snow or kind of melting. And so that may give you an area where some like a AI or something is going to say, hey, there's really heavy snow here, heads up, when in fact it's probably just kind of a melting layer of snow, and it, depending on the temperature of the ground, it may end up just raining and not even being that heavy. But so that's another kind of nuance with radar as well to pick up.
Yep.
And then I also agree. Threw in here with the winter topic. Sometimes you get precipitation and it's not even on the radar. And that happens a lot in the winter with flurries. Yep. It can happen other times of year with rain and stuff as well. But the reason that happens so much in the winter is that the radar is at an angle, where from your radome, where that radar is originating, it goes up at a 1/2 degree tilt. That's the very first tilt. And so the further and further and further away you get, the higher and higher and higher off of the ground you go, because the world is round. And so as the ground curves away, the radar beam continues upward. And so sometimes you can basically just get those flurries to form underneath where that radar beam is, just because of the lower cloud cover and such. And you don't have storms maybe quite as tall as you would when you have your severe weather and your large updrafts and stuff. So that's another reason why you may get precipitation, even though it's not actually happening on the ground. Mm-hmm. There are some other reasons, though, Kai, that you can get stuff either showing up on radar or not showing up on radar, when in fact that's not what's happening with the weather. Do you want to talk about some of the maybe non-natural things that we can get going?
Yeah. Oh yeah. Well, and I mean, there's plenty of energy coming out of the radar, right? And depending on the mode that the National Weather Service wants to run the radar in, it can be more sensitive or less sensitive to various additional things. There are two main modes, and you might see in the social influencer world, they may not have a clue about what mode anything is in. But for anybody who uses a radar app, there are two main modes. There's a clear air mode, and they use a volume coverage pattern of 35. It says VCP 35 on it. And then they use a precip mode, which is VCP 212. It'll say clear air or precip. And the reason
I'm
for
in
that...
VCP 212 right now.
Yes, you are, but Quad Cities is in 35. Because it's been a clear day. And there are targets all over the Quad Cities right now showing up on radar. You know what those are? There isn't a cloud in the sky. Birds, bats, bugs, other things in the air. We can actually see when dust is advected. If you've got a dust storm moving in, the radar can see it. We see fires on radar a lot. Mm-hmm. Fires and smoke you can see. Now, during the day, it's a little bit different in the summer than during the overnight and early morning. And the reason for that is because every night, I shouldn't say every night, most nights, we have something called an inversion that's set up. And just like the ground heats the air, heats the air above it, it also starts cooling first. And so you got a layer of cool air down near the ground, slightly warmer air above it. And so we call that an inversion. When the radar hits that inversion, sometimes the beam it's called ducting. It goes back down, hits targets on the ground. So we call that ground clutter, but it can also hit the tops of wind turbines. And you can actually see on a radar loop, if you ever want to know the difference between a storm and a wind turbine, a storm is moving, a wind turbine is not. Mm-hmm. So if you see an animation and there's a bunch of yellow speckles off to your south or west that aren't moving, that's probably the wind farm in the area that's being picked up on radar. And
I can also see those very well on my radar right now.
Yeah, we actually had a forensic case like that, where the tops of the windmills were causing problems. And we were trying to figure out why there was so much higher reflectivity in those areas. And we determined that there were wind farms there that were causing additional reflectivity, and it wasn't a real thing for the storm. So that is an issue sometimes. We can see traffic. We can see trains. The National Weather Service Quad Cities radar, there's something northwest of the radome there that the beam sometimes hits, and I think it's a concrete mixing tower. And as a result, there's this weird artifacty little beam that shoots up to like Fayette and back. Very bizarre, but when I reached out and asked, that was the explanation I got, which makes sense because the bottom of the beam is hitting something near the ground. But clear air mode is extremely sensitive. And occasionally during freezing drizzle situations or sea breeze situations like the NWS in Chicago, might put it in clear air mode to see the sea breeze front or the lake breeze front when it forms on a July afternoon, just so they can see everything, like the cloud structure and everything, because clouds will be picked up in clear air mode. It'll come up on radar as something very small. But in precip mode, they've got all that figured out, and they'll only filter out the stuff that's actually meaningful.
And yeah, the reason that they change between these modes and don't just stay in preset mode all the time, because you might say, well, if you get if you get all these problems in clear mode, then why wouldn't you just leave it in preset mode and we'll just be ready? Well, it's so that when things get started, like I said, with the sea breeze, or, when you get storms that are just beginning to form, you're not missing anything right off the bat that maybe the preset mode isn't quite sensitive enough for, and then they'll swap it over as things are getting going.
Well, and the Weather Service they'll be using surface observations and satellites, and if they're not expecting anything, clear air mode can save some power too. The radar isn't spinning quite as viciously. Saves a little bit of pedestal wear if you can keep it on clear air mode. There's a beautiful boundary right now, actually, that I'm seeing on the Quad Cities radar. So it's nifty in clear air mode. You can see about everything. But yeah, we see that a lot. It does not mean, when you see weird features in the atmosphere, it's not a sign of any sort of modification or anything like that. The radar doesn't have that kind of capability. It can sense what's out there, but it can't change what's happened. So as a result, it can't steer a storm. It can't break apart a storm. I've heard it all. I've seen it all. All you got to do is go onto Facebook for a couple minutes and you'll be completely mind bent at what you see some people saying. But no, radar doesn't have that capability. It's a detector. It's not a manipulator. It's all it can do is detect. It can't change anything. If it could, we'd have changed a lot of the historical tornadoes in history, and we can't do that.
That's true.
We'd steer them all into the cornfields if we could, but we can't.
Absolutely.
Yeah.
And then one other thing that I'll throw in there also, I guess we were talking mainly about non-natural things, but it can also see natural things that you don't want to see, right? I think, Kai, you mentioned bats and birds and bugs and stuff.
Yeah.
You can see, especially in the evenings, or in the mornings, we call them roost rings, where basically right around the radar, you have a circle of what looks like precipitation, but it's just birds either coming in for a landing to roost, or taking off for the morning. And the other thing is, not so much in Iowa, but in other parts of the world and the country, you can get mountains where, and that's part of the problem with the radar network, especially, along the Rockies and as well as into the eastern US and the Appalachians and stuff. But a radar beam is great for going through the air, but it can't go through rocks. And so then you get, you start hitting things. And so the networks or the radars are a little bit more frequent maybe in those parts of the country because they can't be detecting things through the mountains.
Right. And, even though we've been talking all about NexRad right now, there is a second radar network out there that some of the apps can get a hold of, and its website's a little bit harder, but the apps have a hold of it. There is something called a terminal Doppler weather radar. It's like Minneapolis has one, Chicago has two, Midway's airport has one, O'Hare has one. Those are very high frequency, very short wavelength type of radars that are especially equipped to detect hazardous wind conditions near approach. So they're made for airlines and they're made for wind shear and things like that. So we only use those for velocity data. Reflectivity is going to look really weird. So if you're ever on a weather app and you see any NexRad radar is going to have a K prefix on it, if all of a sudden it changes to a T, you have now changed over to a terminal Doppler weather radar. And if you want to have some fun, watch the next line of storms that comes through Minneapolis and look at it on the NexRad and then switch it to the terminal. And you're going to see a totally different world. But the terminal Doppler is because they really want to get ahead of hazardous wind shear and avoid microbursts at all costs. And so that's why they included a lot of these, what are called terminal Dopplers at a lot of these international airports. It's a huge life-saving investment. The FAA runs those. They're very neat. They update every minute too. They're pretty cool.
Yeah. But they use a lot more energy and use a lot more resources.
Oh, yeah. They're
more
still
expensive.
out there. Yeah,
That's why they're not everywhere.
They're there. Yeah, we wish Des Moines would have one, but I don't think that's just a large enough airport to have one yet.
Not quite. Maybe someday. So we've only got maybe a couple, minute or two left here to throw in the last few little bits, I think, that we want to talk about. And that's some radar artifacts that we've alluded to a little bit here throughout. Kai, you mentioned kind of that refraction situation where maybe in the evening, or in the early morning more so, where you have an inversion and the radar beam gets bent. So there's a couple other things. All of these basically deal with the radar beam being bent in a way that it wasn't expecting. And so it maybe hits some extra stuff, takes a longer path to get back to its origin. All of those things will then result in a anomaly in the reflectivity data or the data in general that isn't actually what's happening. So one of my favorites to look for is hail spikes, where if you have big hail in a storm, maybe it's very reflective, maybe the radar beam gets bounced around. Again, it takes a longer trip than just there and back, and it kind of goes up and down and around and hits a couple hailstones and moves back around and then comes back. Essentially what happens on your radar reflectivity, you have your little storm, your reds and yellows and your kind of little clump of rain. But then there's just this one giant spike, like a unicorn's horn coming out of the radar reflectivity. So that's another example of an artifact that you might see. False echoes, again, same kind of premise, where it takes a longer path than you would expect to get back to the radar.
It's a good sign of hail. Usually it's a good sign of close to 1 inch hail. It might mean a lot of small hail, but I look at that spike and typically I gravitate towards this thing probably has 1 inch or greater hail in it. Probably.
Yep.
Yeah.
Yep. It's usually the best indicator for very large, or best easy, quick indicator for large hail. Obviously, again, there's lots of those derived things, but all right. We dove into a lot. Radar meteorology is a full semester course at many colleges. You can also take grad level courses and stuff. We tried to squeeze it into 27 minutes. So I'm sure there are still some things that you are like, what did that even mean? They didn't even talk about this. Please send in your questions. This whole show is all about figuring out what you guys want to know more about. And so we absolutely develop the show around your questions. And if you have one and you would like to join in on that conversation, let us know what's on your radar. Pun intended. weatheredquestions@gmail.com. That's how you join the conversation. Kai is facepalming me right now.
That's fantastic. Oh my gosh. A radar episode, and then we were asking about questions on the radar. I got it. We're going to be having to go off the radar in a second.
Well, yes, we will be. We will be. In the meantime, let your friends, let your family know. That's the best way to support the podcast. And be sure to subscribe. Take us with you on your road trips this summer. And again, write in with your questions. We're excited to hear from you. Until next time, stay safe.